Yeah. So if you want to do it all, you can. Are we no longer letting Levi have his spot at the white table? What's going on?
I can't sit there.
I know.
Here.
I mean, if you want to.
You want me to move this stuff?
This is super mobile.
You need it.
Yeah, I can just drag it for you. That works.
Wait. Can you pull it over?
Most definitely.
All
All right, we're going to the farm.
No!
Wow.
Not again. Chill.
Wait, we were a kid at farm.
Now,
Remember we made it square?
Oh yeah.
hopefully, never mind, I won't go into that. On the farm is used as something parents will sometimes tell their kids if an animal passes away. Like, oh, they're on the farm now. They're
That's
running
what
free.
my dad told me about my grandpa.
Dad, where's Grandpa? He's running free on the farm. The other animals like him so.
Like grandma.
Dad, what do you mean other animals like him so? Alright, we are gonna build a farm.
No.
No.
Never quite okay.
I'll see my cat there.
I'm not asking a question. I'm telling you what's happening.
Yeah, and you can disagree. Let's play this.
Okay.
Phoenix
Well,
has a student
that's the
voice.
fun thing about me being in charge.
Yes. You're gonna revolt.
You can.
Care less.
Lord of
Although,
Flies.
the 9 of you want to. Ooh, maybe I should. If you want to revolt, I'll throw that one math counts problem from last week at you guys. And the only way you can revolt is if you can solve it.
No.
Average depth of the pool.
I am on it.
We already did that one.
No, but I'm going to change the number.
Chris and I got this.
So you can't just say, like, oh, it's 7.8. Alright.
7.9.
Yeah, when you call it during the class transition, do you really think they're going to hear it? I love our secretaries. They're fantastic. But sometimes they make choices that I'm like, everyone's in the hallway. Nobody can hear announcements. So, in previous lessons, we've talked about frequency. We've done frequency tables. We've done probability tables. We've done area models. We've done all kinds of stuff. It's actually pretty impressive how much we've done this year. And today, we're doing more of it. So, there's a game. So we're not actually going to the farm, all you pouty pollies. There's a game called Build a Farm. And in that game, each player spins a spinner. Half the spinner is red and half the spinner is blue. If the spinner lands on red, the player reaches into the red box, and likewise with the blue. The red box has 10 chicken counters, 10 pig counters, 10 cow counters. The blue box has 5 chicken counters, 4 pig counters, and 1 cow counter. This sounds again like a game I'm going to describe incorrectly. By the way, I thought about ordering Azul. I'm going to ask PTSA for money, but I'm going to try to buy Azul so school has a copy.
Yeah, isn't she the girl in at Last Airbender that was like the evil sister?
Does that matter right now?
Oh.
So, now, here is my challenge to you. We are going to draw a tree diagram to describe this situation, but now, because our math is not evenly distributed, we're going to involve probabilities in that tree diagram. So, based off the description of the problem and how many of each are in there, and I'll highlight stuff, we need to draw an accurate tree diagram. So, red. Crap. The red box has, here we go, 10 chickens, 10 pigs. Your tree diagram can move vertically, or it can move horizontally, like as it goes.
What happened to the little buckets with pencils?
They're up here. When I change the table groups to not be 4 groups, I'm kind of trying to figure out what to do with that.
What question number is this? 79. Who did the homework last night?
I did.
Yeah, Mom. I did it.
I did it actually. I did it in the afternoon.
Who remembers the problem? Okay, I don't know how to do it.
It's most of the time it's just review. Well, like tonight, it's not just review preview. You want to make sure you have written down what it is.
Wait, what?
Tonight's homework is specific. It's not just do the whole thing.
Is that because you just
So if you don't write it down, I have zero sympathy when you do all of it.
You basically do these specific ones where you try to either guess or do all of them.
These are the ones that I have picked out. Like, I picked these out as these are the best problems that I want to make sure you guys know how to do. And I'm doing today's lesson as a 1-day instead of a 2-day because we're awesome and we probably won't be here tomorrow. And my schedule's been screwed up enough times already.
Let's screw it up more.
We're about to. Because we are on target for a test on Friday. Guess what happens if we have a snow day tomorrow?
No,
That gets jacked up.
What just happened today?
Okay, you literally just worked last period, and now you're going to be... My smart board's broken again.
It's our problem. We can have the test today.
No.
We're only like halfway through. It's more than half. No, the unit 7 is really short. Probability of getting cow counting. Head chickens. 1360. Tree data. Can we draw an area model?
Nope.
It's going to be a giant tree model.
The trunk of your tree, or the base of your tree, I guess, is the start of us doing something. Right? The first thing that happens is I spin the spinner, and it either comes out red, or it comes out blue. Now, one thing you can do if you're not comfortable with tree diagrams yet is off to the side write what's going on. We spun. Now, the results are red or blue, but on the stems, we need to put the probabilities or the branches or whatever. I don't like that they call them branches because these are the roots going down. But roots are a mathematical term, so then this all gets messed up. What's probability of red?
1/2.
Probability of blue?
1/2.
We then, after the red spinner, have the options of chicken,
Pig, or cow.
what probabilities go on those?
1/3 for all of them.
1/3?
Chicken, pig.
Oh,
1/6.
I mean, we could go 10 out of 30, but that's a little excessive. Now, I agree with what you said, Thomas, but the chance of spinning chicken is 1/3.
From
What you're talking about is the chance of spinning red and then chicken, which would go out here. It's a 6. I'm sorry. I will apologize for my shortfalls, but I can't really fix it.
that wasn't a big deal. We need your
Oh, by the way, I need to know for sure who's coming.
Wait, so it's on the 8th?
It's on February 9th, that Saturday.
Oh, okay, good night.
Wait,
I
getting it.
yeah,
Oh,
I
good.
have it on my calendar. I have it on my calendar.
You can
So
get
right
blue.
now, according to permission slips, Chris, you're going on the 9th. Levi, you're going on the 9th.
Don't get sick. Your turn is.
Lauren, you're going on the 9th.
Correct.
Kaylee's going on the 9th.
So 1/3.
Thomas is now going on the 9th.
What about the 11th?
Nidden's out of the country. Jacob, are you coming with us on the 9th? You do not believe so. What does that mean? I told you to know for sure by today.
Okay.
You're breaking my heart, Jacob. Steven or Satya, would you like to come?
I have a market concert.
You what?
I'm first to event.
Butterfly.
You have a what event?
First to event.
First,
I
oh,
have
golf.
like, yeah.
Yeah. Satya?
I have an orchestra concert.
That doesn't make anything better.
So it looks like our A team, and you guys have till the end of today when we meet for math counts, then I got to submit our registration. Looks like A team will probably be Chris, Levi, Lauren, and Thomas. So essentially this class. The people going from this class. Hunter, do you want to go? Sure.
Hunter, it's so Come on, Hunter.
I mean, there's pizza, so we can sell you on that.
There's pizza, there's
Lunch
Jacob, if you end up being persuaded to come with us, there's a spot available I just don't know for sure if you would end up with certificates with your name on it, but you can be a late registration. So if you decide the next week or two you want to go. All right, at the bottom of the blue branches, whatever you want to call this, what probabilities do we fill in down here? No, because on these branches, Stephen, what goes on my chicken branch? Half. What goes on my pig branch? What goes on my cow branch? So down here is 1.
That makes more sense now. Who does that?
Because that's already 2/10. And here's what you have to always verify with a tree diagram, which tells you that you're right.
Does it add up?
It has to add up to 1.
No,
These have to add up to 1. These have to add up to 1. These have to add up to 1. And these have to add up to 1. What's 1, 6, 1, 6, and 1, 6 add up to? A half. What's 1? Well, this is really 5/20ths, 4/20ths, and 1/20th, which is a half. Which, yeah, that makes sense. So half and a half. That's good because we go up to we should be a half on this split. Now, let's jot a quick area model for this and make Satya happy.
I like it.
So, if you're right, but it's part of my lesson, so we'll do it anyways.
Wait, what?
If we have, which one was easier? Red, right? Split up better?
Yeah.
Let's go red and blue. Now, can I just chicken, cow, pig?
No. Yes.
If you
Ah,
write the
sit
facts-
down.
You what?
If you're Rex,
I still don't know about that.
It's not ideal, but you can do whatever.
Yeah, but why would we do something that's not ideal?
Good question. You just erased part of it. Oh,
So for red, somebody said I can do this.
yes. I remember doing
And we'll call this chicken, pig, cow. But really, I should probably actually, why did you group all of that? Some choices that the smart board makes. I should probably actually put those in my box, because if we said that we can't continue the same boxes all the way down, I can't really label the heads of the columns. I really probably need to label in here. So chicken, pig,
Good morning,
cow,
Natalie Cox. Please come to the office. Natalie Cox, please come to the office.
1,
Thank you.
6, 1, 6, and 1, 6. So then what about my chicken for my blue?
You can do a quarter. One, that's a half.
So like here, it's half of all the blues.
Yeah, and then like it would be like more than half, like maybe 3/4 on that one,
4/5.
like that.
So wait, this you said this was half, but really at the bottom of our tree, blue chicken, yeah, that was 1/4. So we'd label in the box 1/4. The pig was 2/5, right? Yeah,
No. No, it wasn't.
1/5 at the
It
bottom.
was 1/5.
So that's what I was asking.
Why do people agree with you?
I don't know. I really don't. Me being up here does not mean I'm smarter.
Why would you be teaching us if you?
Okay, that was like once.
So,
And
it
then
happened
cow.
the week before that.
Yeah.
And the week before.
1/20th.
1/10, because it's 1/10 of 1.
Yeah, that's right.
So that's a 2. It really looks like a 1. I'm not making it any better. I made it worse. You're absolutely right.
Now it's better.
There we go. There it is.
So we can now discuss some questions about this and hope that we remember some definitions. You're right. We can throw darts and pick a probability that way. But let's talk about some meanings of words. So here's our tree diagram, or not tree diagram, here's our area model. And if we fill in here, that's why we have the 1/6. And or like we didn't have a half, we have a fourth inside here, right? So they showed the division of the box, which we could write those out there. So if we know, I'm debating where the zoom is actually good. If we know a player got a cow counter, what's the probability their spin was red? And how we actually write that is P of red given cow. So I want you to talk with your partner or think this through on your own. And then if you get done thinking about D and writing out what you believe to be true there, go ahead and look at E for are they independent events, red and cow. So think through those things.
What's the common denominator? 80. I'm pretty sure 6. I know 6 can't go in 8.
So this is the world record. How about 6 times 21?
What's 6 times 100? 10, 13.
How about 16?
Oh yeah, can you 60? 60. Leave it as 10, 13. 10 over 16 plus 3 over 16. The probability of getting 13 over 16 is 1/3 plus 1/2, right? Which will be just 13 over 13. Do you guys get 16 over 13 over 16?
Yeah, 10, 13.
13 60th. I know what's one. Yeah.
For the answer.
I got 60 30.
We got 10, 13.
Discuss how.
10 13 because the
I know.
probability of getting a cow is like
Oh,
13
yeah.
out of 60.
Yeah, you make the cows.
3 of that 13 comes from the 1/10, and then the other 10 comes from the 1/3, right? Yeah, I know. So it's 10 13.
Yeah.
I know. Alright, sounds good. I think we all
Good
got it now.
I just need to figure out how to write it.
10 over 15.
No.
10
Line
line
13.
And then
Line P.
Can anyone come show the work to support Y?
Yeah!
Chris had his hand up first, so we'll let him go with this one.
I want the area model.
get this
I would
up.
like the area model.
Please be
He would like the area model.
It's on the TV. Are you wanting this one? You
This
mean?
one. Because
He
then
wants
I
the
can-
area model.
Let's do that.
Okay, so we can take this cow. And that's 110. And then we take
120.
this 120. Doesn't matter. 120th.
Okay, erase that and fix it, or I'm gonna have you sit back down.
Okay.
It does matter.
Sure, I'll come to the board and slop up some nonsense.
120th. And then we can take this cow. That gives us 1 6. So now we gotta add these together. And we can do that. We get 13 60ths.
So we're all good with equivalent fractions. How we get to that point?
Yes.
Okay.
And then so we know that this 3 comes from 120th, and then the other 10 comes from this one. Because 1/6 is
So wait, why isn't it just 10/60ths?
Yeah, because 1/6 is equal to 10 60ths and 120th is equal to 3 60ths.
Questions?
Wait, so you
You
guys
know
said
how
10
this works
13.
and you're still
Yes, 10 13s, and we're about to simplify. We're about to finish this.
Oh, okay. I wanted to make sure.
What
So-
is your 13/60ths representing?
13 60ths is the probability of getting a cow
Out of
out of everything.
cow compared to all outcomes. Then,
Since we know that on red, the probability of getting a cow would be 1/6, so that's 10 60ths. And the probability of blue getting a cow would be 3 60ths. Hold up. We do 10
Hold up,
hold up.
here's what Chris is describing, if you're not sticking with him. This is 13 of this 60. We should use red or something at least close to it. This is how many of the 13? 10. This is 3. So 10 13ths or 3 13ths. So these given situations, I may actually go ahead and write real quick. So in your notes, please write P of red given cow. If you didn't write it yet, P of red, not reg. Here's how this works. How many parts red compared to how many parts cow? So if I asked you P of blue given cow, that is 3/13. If I ask you P of cow given blue, 1/10. We already figured out cow given blue. The chance of cow, we said, is just a 1/10 chance out of all the, like, once we're at blue. So this is already blue, or sorry, cow given blue. It's when we turn it around that it gets a little bit compound. Blue given cow, right? Because the color happens first. Does it make sense how we got our 10/13ths?
Indeed.
So now the question I need you to ponder, discuss, and or fight about is, are red and cow independent events? Discuss.
The chance of getting cow depends on whether you get red or blue.
So what does that mean? Are you saying yes or no? Independent or dependent?
Cow depends on red. Red is independent.
So are the events independent?
One is independent. What do you mean?
You can't have one independent and the other not. We're looking at the two events, cow and red. Are they independent or do they relate?
They relate. Red affects your chance. They relate.
That's what I'm trying to have you guys discuss.
Do we all agree that they're dependent?
They do relate.
They're depending, but
I don't get the joke.
weird. Then probability and
Oh, I think you don't like finish. We probably just hear things. Oh. Some of those are rectangles.
All of them are rectangles.
Oh, Jacob. Jacob, do you remember the blue rhombus?
Oh yeah.
Mr. Hudson, yesterday at Ski Club, instead of the black diamond, we called it the blue rhombus.
I like it.
No. It was instead of blue square, we called it blue round.
Hey, yesterday was probably okay. Well, how was the skiing with it being so warm? Yeah. Was there decent snow left?
I mean, yeah. It was like,
I should have done Ski Club. I wanted to do
Wait,
Ski
I
Club.
wouldn't high
Parents
school.
don't let me.
All right. Here's how we determine if they're independent.
Too broke.
What is the chance of cow? 13/60ths. What's the chance of cow if you get red? Well, 1/3, really.
Yeah.
If you already have red, it becomes 1/3. Now it's 1/6 if we look in the whole sense. But what's the chance of a cow if I get a blue?
10.
So does red impact cow?
Yes.
Yes. Are they independent?
No.
No. If one impacts the other, they are not independent. So cow depends on red. Red doesn't really depend on cow because red happens first, right? Cow depends on red. Red's just kind of doing its own thing. Yeah, because it doesn't let peer pressure affect its
Do you guys remember that
decision
game where, like,
making.
a cow or different animals?
Huh?
Yeah, they
All right, last one for this problem. What is the conditional probability that if you got a pig counter, your spin was blue? So how do we write that prompt? P of how do we write this?
P of blue given pig. Yeah.
Yeah, so we got a pig. We're looking at blue. So it's probability of blue given pig. We know pig has to happen. So remember, the given determines our denominator. Then the ask determines our numerator.
What if it is once again?
Hmm?
6
Yeah, so how much region in total does pig cover? 11 if we look at those like, well, wait, a 6 and a 5th. I can't just add a 6 and a 5th like that.
11:30.
11.
Oh, 11, 30. So this, now,
You're like,
I don't like that it's blue, is 11 out of 30. So then 11 goes down here.
Yes.
And then, so that'll be 6. Yeah, so 6 over 11. Genius.
Are we sure?
Yeah.
Oh, it's 1 fifth, not 2 fifths. That's pretty sure.
I just want to make sure no one is looking at this 6. Remember, this is 5/30ths. That's not the 6 we're looking at. This is 6/30ths. This is what we care about. These two fractions tell us the total region is 11/30ths, and 6 of them come from this blue region. All right, check out 80. Except no one has textbooks out, except only Thomas, so I will scroll so we can see. Thomas, thank you for having your book.
Thomas is smart. Mr. Hudson.
What?
I've had the book the entire class.
Okay, I appreciate it. Thank you. Sorry I didn't see it.
Yeah, there
I
you go.
genuinely am sorry I did not see your book.
I want to be
All right,
obligated.
I don't want to help you with this. So, read, dive in, try to determine your answer.
Okay, so we draw. No, we have to draw a tree. We can just draw a diagram. Do an area model. You see that there. So what's on the left side? Coin and die, right? So first you cut it in half, right? H T.
Okay. So on the left side is our
Coin flip and die. So 3 out of 10, 3 out of 10, 4.
Eventually. No. No, we do not. Because when we get half, that means that it's the whole. And then we can divide that up into 3 special.
Okay, this is gonna be hard to draw with an area model. Exactly, so yeah, that's why you always look for trusty trees out here.
Is it really going to be hard?
It's gonna be
It's gonna be
complicated.
long. It's pretty long.
3/6 of 10, so that's just half.
Or 1/2, 1/2.
So it's gonna be 3/20 for
Well, cute with 3 red stuff together. Okay, so it's still red, yellow, and orange. Yes, it ends up with here comes stuff. So y is 4 out of 10. Wait, is it if you win? Which you're right. Okay. Okay. If you win,
Yay.
yellow.
And then we get tails. We have a cube. This.
That. So that's 1/2, 1/20. Then 1/3, 1/6.
Okay.
So that'll be 1/3.
We have 3 red.
And then 1/6.
That's 1.
So that'll Wait, is it if you get blue off either of these, you get a stuff too?
Si, senor.
Okay.
Okay, what's the possibility of
Stuff
winning?
plate.
Well, yeah, but it's 1/6 of the total.
Oh. So you circle the V and that gives you a dove.
Yeah, that's 1 and I even.
Okay. Oh, it's right.
Yeah, Jacob.
Yellow,
Yellow, that's one other. That's what I was thinking.
That's what
And then
Yeah.
blue, that's 1.
Yeah, that wasn't that hard. I feel like this is probably more complicated. No, I said, what's the probability you started off by flipping heads? Blue's half
If the player ends up with blue, they win a something.
Oh no, okay, so it's like what's the it's like the same
Okay,
as
so it's
Oh, I
probability.
see. I'm getting a stuffed animal when you oh, I see.
Yeah.
so it's head given.
Okay, so
given
that'll be
blue.
one
So it's
half.
head given
So
by
you have one half. And then
that was my thunder.
You weren't listening.
your thunder has been
destroyed.
shortened.
My taketh. He taketh thou thunder.
That one's you.
We don't talk about that.
I had to look it up. So
914
I had
is
to
this
look
speed.
up what Dallas meant specifically.
Did you use that in your sonnet? 320
I was
Sonnet.
going to, but then it meant the wrong thing.
But you guys
We
have
have to
to
do. Yeah.
It
I
does.
got extra credit.
No, it's 20.
You guys an honor.
Yes, you forgot to multiply.
Yeah, I'm doing honors now.
So we can do 60.
English is struggles. I'll wait for next year. I'm actually. Are you guys gonna do
What?
Are you guys gonna do like science over the summer?
What do you mean? Wait, does that
You
mean
can do freshman
Hey
class.
guys, you're 100% off topic. I love that you're talking about high school, but that's what like AO extensions and lunch are for. I only have 12 minutes left. We're nowhere close to how far I want to be. Flip a coin. That determines what we do next.
I am.
Giant wheel from heads. Number cube or color cube from tails. So you know heads, tails, 1/2. Standard coin.
Okay.
And from there, my probability of red becomes
What's the probability of flipping a coin and landing on my head?
3/20ths or 1/4. My probability of blue becomes 3/20ths or 1/12. And my probability of yellow
Becomes
Work.
420. Half it. 420. And then that's
Simplifies better.
yeah, we could simplify if we want. Now, sometimes it's actually better to unsimplify. Those are all in 20ths. We have 4ths, 12ths, 12ths, or 6ths. Man. 60ths, right? So, I could just go ahead and say 9/60ths. I should shrink this down. 9/60ths. How many 60ths?
5.
5.
No.
12.
Oh, for this one, I thought you meant the other.
Wait, why did I write 5?
I don't know.
Why did you write 5? I was just thinking he was already done all.
I legitimately wrote 5.
We hear you. We don't know why either, though. What do I have to multiply 4
Oh,
by?
you don't have that handwriting, I'm sorry.
You managed to get a 5 and 12.
Ask me questions like that. That's decisions happening in my brain that I'm not sure.
Why
You look like you would have walked around all over.
I don't know.
What is
Lou?
That would be 4.
And now you're not sure.
Or no, yeah, 5. 5. No, 5. I meant now it's 5.
Don't put it in our box.
I and a half.
No,
Put it in a circle.
This isn't okay.
So wait, did we add up to 1?
Yes.
Circle, circles,
Yeah.
rectangle, triangle, and
There
polygon.
are no
Add to 1.
circles, only ovals.
20, 30, 42, 51, 60. Yeah, we got it. So now, suppose that didn't work. Suppose that you know Tyler won. How many ways are there to win? 2. It's funny if you can get the balance right, because it just like kind of spins correctly. How many ways are there to win? 14, right?
Wait, what?
9 over there, 5 over here. If we're working in all common denominators, our life will get easier.
There's only 2 blues that you
So
can get.
I didn't guide you to this in the first problem. Just listen. I didn't guide you to this in the first problem. But your best bet here is put everything into common denominators, because then the amount of ways to win is always just the numerator. So if blue wins it, we have 14 here ways to get blue. Doesn't matter out of what, we have 14 ways. It's out of 60. So our real chance of winning, if we just say the probability of winning is 14 out of 60.
Which
But-
is about 7 out of 10.
But if we ask the question, assuming we know he won, what was his chance of having a heads at the beginning? What was 9/14ths? Because we now take this as our amount of blues, and we say the probability that he had blue, or sorry, he had heads given blue, like given the blue result at the bottom. Well, blue, there's 14 blues. How many of them are from heads? 9 out of 14. Questions on conditional probability.
Wait, where?
On question 83, earlier in the day, space, comma, space. My father said.
I don't
Okay,
what?
Thomas, there's a typo. It
It's
has
on
to
your
be.
polygons.
Oh.
All right. Now, with the remaining time that we have, I would like you guys to start looking at 81. Set up a two-way frequency table so that I know that we didn't just totally blow off class yesterday. Raul.
We already first getting. We did frequency tables in like what?
Math 1. Well, Math 8 probably is when you start to begin with. Actually, dude, my buddy who teaches elementary is doing two-way frequency.
So are we doing 80 now?
Because now we're doing
Why are we doing addition
applications.
now?
Satya, the direct answer is because now
Why
we're
are we adding
applying two-way frequency tables.
Why are we adding fractions now?
No, we know how to add fractions already.
78 students.
We know how to two-way frequency tables.
So that's
Where's what? Pencil sharpener should be with the. Yeah, it's right there. It was
39%.
Actually, no, snakes don't bite people unless provoked.
That's not true.
Yeah, it is.
I don't know where you heard that
I mean,
from.
they're
Okay,
ways of
fine.
being
Anything provokes a snake then.
pretty
I've
much.
had
Yeah.
a snake lunge at me, dude. Let's
Like,
talk.
walking near a snake, they're going to be like,
Now, but
Why are
if
you
you find,
walking in my
if you
area?
find a snake that is sunning, they normally are pretty docile because they're like really tired from
Have you
absorbing
ever
all the sun.
been bit
No.
have you ever
Never
caught a
mind.
garter?
No, I take that back. I had like a black snake or a garter snake like trying to bite me, but he was so small, it was just like meh.
I love garter snakes.
Because out at camp, we would like take any snake we found over to EcoCon, which was ecological conservation was the part of camp. We had a rented, like borrowed from a pet store, like big old anaconda that we'd like walk around with, and that guy was cool. He was pretty docile.
And
Then we had littler snakes, and those guys were normally more like aggressive because they're small. Like, the big snakes don't really do a whole
Boy
lot.
Scouts, my friend,
Depending
they're just
on-
like, oh, there's a person there. Nah, whatever.
Yeah,
I
like,
ate a cheetah earlier.
I can crush him if I want to. Like, I don't need to.
There's no
There was a couple times that I had that dude on my shoulders walking, and he'd start to like you just feel their muscles kind of tighten a little bit, and you're like, you get a bit nervous because they're on your shoulders, like around your neck.
Which one?
I ate a snake
The
on
big anacondas that just hang out. There's
I
also
had one
like
do that
pythons and different
today.
things. One of my friends had a python.
They-
All right, so 78 students have access to a car on weekends. Okay, 78. 54 students have regular chores assigned at home. 80 students neither have access to a car nor any chores to do. So no chores, no car. Okay, so this is 80. And wait, so
Oh, I know.
the 200 is like a total, right? Whether we're totaling chores or totaling cars.
70 students have access to.
39% of students have access to a car.
So wait, how do I use that 78? Jacob?
Oh, I know how to do this now.
Below the column with cars.
Okay. How do I use the 54?
Next to the row with chores.
Okay.
Can you fill it out from there, or do you need one more?
You tell me.
78 plus whatever's in no
Yeah,
row
you-
should equal 200. So you subtract 78 from 200. And then you can find
And
what
then
goes
you can
in no
do
column.
122 minus 80. What's 122 minus 80?
40. Good question.
42.
And then you get the 12 from chores.
12 and then 6.
And then
42 have chores in their car.
67.
Yeah, 66.
And you still have
Sounds good.
That was pretty easy.
That's not fun.
Don't say that. There's going to be something
Then he gives us more.
Yeah, I know.
So,
new.
what's the probability you have access to a car given that you have chores?
Well, let's see.
What's the probability?
1278?
1278.
No.
12,200.
1254.
No,
wait,
no,
wait,
wait,
no.
1254.
I hear 4 different answers right now.
Why would it be 1254?
Well,
The
probability of getting a car when you have chores.
Because that's the
Two
total.
nine.
Okay.
People have chores.
Even if you have chores, what's the probability of having a car? It's
Where's
1254.
homework help on notes?
1254.
What's the probability of
Because
the person who has a car?
2 nines
You're
or 12.
If somebody is confident enough to assert an answer to the class, and not Chris, because he showed how well he cares about what he writes on the smart board. Steven!
No, I
Come
don't
on,
care.
you haven't really participated a whole lot. We'll let you If you tap the pen, you can change what you're using, color or highlighter or whatever. Down at the bottom, that
That's
little
a nice
icon, see
door.
right
I don't
there,
think
that
that's
will let you
doing
change
it on
what
the
you're
car.
doing.
Okay. So, this, okay, so it said probability of,
I'm just asking. Like, I'm just
where is
asking.
it? Oh, is it
It's
not on
car
there?
given chores.
Okay, so car given chores. So, chores, 54 people have chores. If you just take that, 54, and then from there, it's either you have car and no car, and then people that have cars, just 12.
So why I'm asking you these random questions that aren't directly in the book is to practice how do we set up these given probability situations. Now let me flip that question around. What's the probability you have chores given that you have car access?
1278.
1278s, right? Same numerator. The numerator's chores and car. But the given situation changes your denominator. So which is more likely? That you have chores given a car, or you have a car given chores? Car given chores, right? So we could say it is more likely a student has a car if they have chores than it is that they have chores given they have a car. Now, here, this is all just trying to relate it to you, but this is real world statistical data that we will present and say it's more likely somebody has like a heart disease given that they are obese versus given that they have a heart disease, what's the chance they are like these like things in the medical field or in like science. This is why we're doing this. Okay, so that age-old question of why are we doing it's seriously how people present data in the real world. Okay, that's all the time we have, and we did use all of it.
I want to point out these senior students are spoiled.
Yeah.
Ones that do chores have less of a chance
I
of
didn't
having
push it off. I closed my binder.
Well, so the ones that have chores, most of them don't have a car.
Yeah.
The ones that don't have chores, still most of them don't have a car, but a lot more of them do have a car. I don't really think that's appropriate.
Yeah.
Right? Like but my personal opinion is
I
everyone
like-
should have chores.
I like sort of do chores.
Yes.
I might have a problem.
I mean, I help out.
So that data is not very useful for us. I sort of do chores. I might get a car. Go to lunch. Have a great day.
I
Yes.
lost my headphones.
Okay. What are they?